Welcome to the Alpha Training and Consulting's online training program. Today I'm going to answer the question, what is standard error in linear regression? That's a great question. We'll be discussing that. Remember to keep us in mind for all of your ASQ certification preparation needs. We offer a lot of the classes to prepare you for those great certifications. All right, with that being said, let's get started here and explain what the standard error is. First of all, it's all about linear regression that we're talking about today, and this is the x-axis where the independent variable resides, and I have horsepower here, and my y, even though I didn't label it, that's top speed of the automobile. So obviously you expect as you add more power to your car, your top speed would increase, and that's why there's of course an upward trend here. We call it a positive slope. Now, this is a situation. We did least squares on this. That means you draw a line right in between all these dots. See, these dots are data that's collected. So at this horsepower, I had this power. Or I'm sorry, at this horsepower, I had this top speed. And at this horsepower, I had this top speed. At this one, I had here, etc. At this horsepower, I was here. At this horsepower, I was up here. And over here at this larger horsepower, I had this top speed here. Okay? And so then we take this data and we have what we call least squares. And least squares puts this line right down the middle, the center of gravity, if you will, of all these dots. They call it least squares. And so that's my line. And that line, whenever I put a horsepower value in and go up here and hit that line and go over, that will tell me the miles per hour for a given horsepower, for example. And they call this blue line the expected value. This is the expected value. All right, but look at that. It may be the expected value. By the way, the average of a distribution is often referred to as an expected value, the average. So you'll see that in some textbooks as well. So, but this blue line would be the expected value, our linear regression equation. Now look what happens though. I go over to this horsepower and the expected value would say, okay, it's 160 units, 160 miles per hour or whatever. Okay? But in reality, I didn't get that speed. I got this speed. And I go over and it's 150. So there's an error here. Okay? The equation says the expected value would be 160. I got 150. So that's an error. And we call that a residual. Some people call it residual. Some people call it an error. So that will be the residual or the error right there. And of course these other ones have errors also if you go over here, and the real one's up here. But this error here is 10. Okay, 150 or 160 minus 150 is 10, so the residual is equal to actually a negative 10. It's actually below the expected value. So that's step one in understanding standard error, is understanding this error, also referred to as a residual. So now that we feel comfortable with that, I can explain what standard error is. If I took a squeegee along this linear regression line and I squeegeed all these points down, and I put a wall right here and I just squeegeed them all down so we could see how frequently the standard errors took place. It is very common, I've checked it many times, it is very common on linear regression equations that this error term or these residuals are normally distributed. So yeah, if I squeegeed everything down, got all no space between the dots, it's very common you'd see that that error is normally distributed. Now, if you take the spread of that distribution and divide it into six equal spaces, then that would be a standard deviation, and that's true. And but when you do it to residuals, we don't call it a standard deviation. We call it a standard error. So a standard error is the standard deviation of the residuals along an expected value here. So hopefully that makes sense. A standard error. Why do we want to know the standard error? Because it gives us an idea that if I go over here and use this equation, it gives me an idea of how much variation there is about the expected value. And of course, I can also run confidence intervals, so I could take the expected value and add and subtract, for example, 3 standard errors. And that would give me a 99.73% confidence interval. What does that mean? Well, if you go over here to 150 horsepower, go up and go over, that will give you your top speed. Okay? Top speed. But if you add and subtract 3 standard errors from it, it gives you a confidence interval, and say 99.73% of the time I would expect the actual value, not the estimate value, but the real value to lie within these plus minus 3 standard errors here. And of course 3 isn't the most common. Usually it's 1.96, correct? Because that would give me 95%. Most people work in 95% confidence intervals, so they would change this Z statistic here from 3 to 1.96. Then you'd go up here and you'd take the expected value, expand it by 1.96 standard errors plus minus, and you'd say 95% of the time the true value will lie between that confidence interval there. So standard errors are very important. The standard error is normally distributed is an assumption on quite a few studies. The ANOVA, one of the assumptions is that the residuals are normally distributed about the expected value. So there you go. That's what standard error is. Hopefully that was helpful. Please keep us in mind again for all your ASQ certification preparation training. I have websites for all these various classes. Take a screenshot if you'd like, or pause this video, pick out which one you're interested in, and go check out that website. It'll tell you all about that that particular class. Boy, we'd sure love to have you as a student. If you have any questions, please let me know, and I look forward to working with you in the future. Thank you, and have a great day. Goodbye.